Well, hello again everybody, and today I'd like to start by wishing all of you a very happy Christmas and a prosperous New Year. Well, because it is still Christmas, well just about anyway, we've got a radio with a Christmas tree on it, because I thought that would be just a little bit festive. So the Bush DAC10 is actually classed as a British radio classic, and I'm sure many of you will be very familiar with its design. So the Bush DAC10 radio was originally introduced in 1950, and it uses a very similar chassis to the DAC90, but is slightly less miserable. Now originally when these radios were manufactured, they sold for the actual grand price of £14.10, but apparently that was actually later reduced to £13.19. But one of the interesting features of the DAC10 is that it has push button tuning, and that allows a number of preset stations to be tuned in. Okay, let's go ahead and take a closer look. So we've also got a serial number on our box here, which looks like 6259, and that could be 13 or /37. I'm not sure. We'll have to check, won't we, to see if the serial number on the radio actually matches the serial number on the box, because you never know, maybe some shenanigans has gone on. Well, it says here 1 of 11 that was supplied to Messrs W.J. Elliott Limited, 16 Checker Street, St Albans, Herefordshire. Now apparently this W.J. Elliott and Son, this is where the guy who went on later to form the company that we all know and love as Rumbelows, well, he actually learnt his sale technique and how to sell radios. He actually learnt that working for this W.J. Elliott. And serve you right at Rumbelows. And it's also got the postcode here for Bush's manufacturing plant, which was in London, W4. Are we ready to take a look inside? Well, I've got to admit, I'm actually quite excited because I've not had a look inside this box either. This is the first time I'm going to remove the radio from its actual packaging. So let's see what we've got. Hopefully it isn't just a bag of broken plastic and valves, so fingers crossed, eh? Well, on first inspection, I can't see any damage, doesn't appear to be anything rattling about. The actual finish on the Bakelite here is very, very dull. Actually, it's unusual dull, but the dial glass looks in very good condition. Let's go ahead and take it out. Oh, quite a snug fit in its box. Have we got any other notes or anything inside the box? No, shame, we haven't got any manual or anything. That would have been nice. Well, we've got our serial number, which is 6259248, and there's the serial number on the box, which is a 625937. Looks like we've bought a ringer. Well, it doesn't matter to me at all because I'm not a serious radio collector, I just like repairing them, but this actual box is for an older radio. This is a later serial number on this radio, which you could say is a bargain because I've got a slightly newer model off the production line. Now, one of the things that I do like about these Bush radios is this kind of a nice patina, but it's almost like a wood grain effect that you get on the plastic moulding here, on the phenolic resin. But this one does actually look very dull, so I'm hoping that it hasn't been over polished, because if somebody tries to rub these down too much, you can actually go through the surface on them, and yeah, it can be damaging to the material underneath. So I'm hoping that this hasn't had that done to it, and it will respond to a little bit of cleaning. Well, previously I did buy some of this paste polishing compound number 5, which apparently is the dogs when it comes to cleaning Bakelite. Well, before I go ahead and do the whole radio, I think we'll just try a little corner here. Oh, it's surprisingly abrasive, this stuff. Okay, well I think that should actually clean up okay with a little bit of work. Doesn't look too bad. Well, I think that's enough baby sham for you. Let's crack on. Now, I've got to admit, I'm not really a massive fan of these DAC10 radios for a number of reasons. And I guess I might start off by giving a safety warning, which I don't normally do on my videos because everybody's entitled to get an electric shock at some point or other, and generally it's the best way to learn. But this is what they call a live chassis radio, which, as the name suggests, we've got some metal work here, and it is possible for the actual metal work, the chassis, to become live on this radio. Okay, that looks in very good condition. And it looks like there's a nice protective layer of dirt inside, which is another good sign because maybe it hasn't been messed around with. Yeah, so I was saying that this radio's got a live chassis. Well, that shouldn't really present too much of a problem if the radio is wired up correctly. What can happen is, okay, here's the mains lead. Depending on which way the plug is wired up, the chassis could be wired to the live wire or the neutral wire. Now, if the chassis has actually been wired to the neutral wire, as it should be, all is good. It's I'm not going to say it's safe, but it's certainly safer than if it's been wired to the live wire. So that's what can cause you problems. Now, it may not be just a problem with the wiring of the radio. It could be the plug that's been wired incorrectly. And of course, in a lot of old houses, in fact, I had a house where one of the main sockets turned out to be wired the wrong way around. So, you know, you may find that this radio would operate perfectly safely in some places. You'd plug it in somewhere else and find potentially the chassis became live. Working on one of these live chassis radios does present some operating problems, some servicing issues. So I'd probably say that it's probably not the best radio to work on as a beginner, because you are more likely to end up with an electric shock. Now, the other thing about these sets is they don't actually have a transformer in them, so it does mean that if you do get an electric shock, you're actually capable of you know, driving quite a lot of current into yourself, which is going to make matters a whole lot worse. So, as I say, perhaps not the best radio to start with. The other thing I don't like about these radios is that what I would call built down to a price. They're just not nice to work on. They've got a very sharp chassis, they've got lots of sharp jagged metalwork. It's actually very hard to get at certain parts of the radio to actually do anything. They're just not very pleasant things to work on. So I generally do avoid these, although they do have you know, quite a pretty case, you know, quite a stylish enclosure. Although I always joke to all my friends about how much I hate them. I call these radios constipation turds, but they seem to get a very big following, and I guess they get a big following because at least it's not, you know, it's not a little brown box, unlike, you know, something as totally hideous as the DAC10, for example. Okay, looks like we might have a screw missing there. Is that loose? Okay. Oh yeah, some lovely filth in here. Well, this is a first. I can actually see that we've got a warning label on the back of this radio, and it says something like, "Caution, do not operate receiver with," although I can't see the lettering after that, it's all smudged out, but I'm guessing it's probably something like "do not operate receiver with case removed" or cover removed, because, as I say, this chassis could actually be live. Now, also taking a look at the mains lead on this, again, unusually, the actual mains lead, quite a nice lead on it. I can't see any damage on it. It's all flexible, it's not gone hard and flaky as often is the case. Don't know if this is a replacement lead or not. And of course, it's got the red and black wires, which I'm glad to say that now England has finally left the EU, this is what we'll have in future in all our plugs. We're going to go back to having red and black wiring, of course. So before going too deep into a radio and actually cleaning everything, I do like just to take a good look. Now, I can see that these two valves here are lovely and clean, where all the other valves have got a big coating of dust on them. That of course may mean nothing at all, but it could also mean that at some point in the past these valves have actually been replaced. They are all Mullard valves though, so they are actually a matching set, although it could also just mean that for whatever reason somebody cleaned them in the past. Maybe somebody's had them out, I'm not sure. So just taking a look at the burning on all these valves, I can actually see that these have got only very slight discoloration, whereas as we would typically expect, I'm guessing this is maybe an output pentode, and we've got a rectifier valve at the far end here. These are actually quite badly burnt, you know, they're silvered at the top, because these valves, the output valve and the rectifier valve, probably run, they're the hottest valves in the set, and they're also located next to this dropper resistor, because I don't know if you can see they've got a green resistor inside here. So this green thing here is actually just a big kind of porcelain clad resistor. It's a big high power resistor because, as I would have said earlier, this set doesn't have a transformer in it, so we actually drop from the main supply down to a lower voltage using this big resistor here. And the other thing that we're going to find is actually the filaments of these valves, the heaters, they're actually all going to be connected in series with each other, and then that series chain of heater filaments will be connected again in series with this large dropper resistor. So I've blown this thing off outside with the air duster, and I seem to think there's a couple of screws in here that we actually have to undo, and once we've done that I think we should be able to withdraw it from its plastic enclosure here. I'm glad to say that so far this radio looks in fairly good condition. I can't see any damage on the case. None of the screws look too mangled up. I'll soon put that right though. Notice some of the heads on some of the old screws are really kind of narrow. They're almost like knife blade thin. So I keep this very old grandad screwdriver. It's actually a lot sharper than a normal screwdriver, but it seems to fit some of these cheese head screws. It actually fits them much better than the modern screwdrivers, because the modern screwdrivers do tend to be an awful lot wider. In fact, just looking at that, that's a really poor fit, whereas the old screwdriver here fits a lot better. Why won't this come out? Oh, there we go, just a bit stiff. So it looks like we've got a wire from our output valve which is going up to our output transformer, which appears to stay in the back of the case here, so we'll just have to actually release that. Now before I move the cabinet off the bench, there's something I want to show you here on the speaker. Now I've got no doubt that you've all looked at loudspeakers before, but this one is slightly unusual. As we can see from the badge here, it's a Celestion speaker, which was a very good make of speaker, a good quality speaker. But the interesting thing about this speaker, you can see that, well, it's kind of missing something. Normally for a speaker we'd have a big magnet on the back here, wouldn't it, which would work in conjunction with the voice coil to actually make the speaker diaphragm move backwards and forwards. Well, this magnet is suspicious in its absence. Well, it has gone AWOL, but it hasn't gone very far, because what they actually did on this particular speaker, to actually make it lower profile, the actual magnet is actually installed on the other side of the speaker. I don't know how common that was, but certainly this is the only radio that I'm aware of that had this special Celestion speaker with the magnet mounted inside it. And I guess what it allowed them to do is maybe just make the case a little bit smaller. I think an awful lot of effort went into this radio in what we would probably call value engineering these days. So I'm guessing they did things like, well, let's put a smaller low profile speaker in it to make the cabinet a little bit smaller, maybe use a little bit less material. So that's my take on it anyway. So we've still got quite a lot of dust built up inside here. Oh, and I've actually also seen, that's useful to see as part of our examination, we've got some wax here. So some wax has obviously been melting off some capacitors, and it's dripped down onto the case here, and yeah, it looks quite black and horrible, this wax. So I kind of wonder, you know, that could have happened the first time the radio was ever switched on in its case, of course, that could be normal, but I suspect more likely what it means is we've got some waxy capacitors which are going to need changing. So taking a look where we had the drop wax on the cabinet, that does actually perfectly line up with a capacitor here. So I think this is the modulation hum capacitor, which is actually installed across the mains of the radio. And I can see that it's actually quite badly charred and melted, and there's an awful lot of wax here which has dropped down. It's dropped down onto the mains wiring, because this is an across the mains capacitor here, and of course they are the usual culprits. And if this one hadn't already been cut out, because I can see somebody's been in here and they've snipped it off, if this hadn't already been cut off, I would have gone in here and I would have removed this capacitor, because we know that these are wired directly across the mains and they are just prone to going bang. And the first thing you want to do is you want to remove these capacitors, and you want to replace them with the correct type of safety capacitor, one that is actually rated to be wired across the mains. Now, having said how this radio was really quite cheap and nasty and built down to a price, there is actually some surprisingly nice features which they've actually done at some expense, and I would actually say is quite unusual. So you can see that they've actually bothered to put a scale down here. Now, this scale isn't visible to the radio operator. The only purpose of this scale down here is to be used as part of the radio's alignment. So it's actually got all the main dial marks actually marked down here as well, and there's a little tiny, you won't be able to see it on camera, but there's a little pointer here which actually lines up with this scale. So obviously that's designed to actually aid in the alignment of the radio, which is actually a beautiful feature, so I'm not going to knock this radio for that. So while we've got the radio in this orientation, we can also see the RF switching bank here, which actually allows to switch between, I think it's medium wave and long wave on this radio, but it has some other features in that it has push button tuning, which again is really quite unusual. It's not something I've seen very often, to have push button tuning. So what you could actually do is you could actually preset, I think it's 3 channels, because we've actually got the adjustment points just lower down here. I think that's 1, 2, 3. So what you could do is you could actually preset 3 separate channels on here and then just push a button and your radio would automatically tune to them, which is, well, it's an unusual feature and quite a nice one. And quite nicely, again, these have little scales against them, which aren't going to be super accurate, of course, but they're going to give us an idea that when you're hunting for your radio, when you're trying to set up these preset push button stations, these are going to give you an idea of where they are. It looks as though they could be maybe one long wave. There's going to be 1 long wave preset, and it looks like maybe there's 2 medium wave presets. Again, I'm not an expert on this radio, it looks like it's something like that. And maybe we've got a better angle now on this across the mains capacitor, which, as we said, it has been snipped and it has lost all its wax onto the volume and the on and off switch, which is positioned below it. Now, I don't think we'll reconnect this at the moment. It isn't really going to do any damage blowing in the wind, and it's not going to stop the radio from actually working. I think what we'll maybe go ahead is, I'm just going to change out this grid coupling cap now. We'll put some power on it and give it a go. Okay, it's ESR capacitor bingo. Let's see how we do. Now we've actually got 2 segments in this filter capacitor. We've got a 16 and a 32. Okay, so this has come up 36.5 microfarads at 0.47 ESR. So that looks damn good to me, actually. Let's see what the other one comes up. I'm assuming that's a 32 and not the 16. Right, and the other one has come up 21 at 1.2 ESR. So that one's a little bit high, but it's not disastrously so. So the actual capacitance value is higher than we would expect, but not ridiculously so. I would have thought what we'll do is we will go ahead and we'll power it up with this capacitor in, maybe with a plan to change it out later, but I think it should survive enough to do a little bit of testing. Well, as we call it in the radio trade, here is that capacitor, the famous that capacitor. So the reason that we want to go ahead and change this capacitor out is because if it's at all leaky to DC, it's going to try to put a positive voltage on the grid of our pentode valve, and the pentode valves are very sensitive to that. They'll conduct very heavily and it will damage the valve. Yeah, it's pretty much any valve radio that you work on. The first thing to do is almost certainly to either replace the grid coupling capacitor, or what I'm going to do is I'm just going to put another capacitor in series with it, which is a little bit of a bodge, but yeah, it's absolutely fine. So even if this capacitor does leak a little bit, the second capacitor will stop it getting into the grid of our output valve. Now, of course, that does change the capacitance a little bit, but it's not at all critical for the job that this capacitor is doing. Now, this is only temporary, so I'm not bothering to actually make a nice job of it. But that should do for now. Now, the other thing that I should have done earlier, which I didn't do, I should have gone ahead and I should have just checked the resistance through the resistor, through the mains cord, because we want to make sure that none of these valve filaments and our dropper resistor, we need to make sure that we have continuity, because if any of the valves have failed, they will go open circuit and the radio won't operate. So that's actually showing 1.4K at the moment. I'm not actually sure what it should be. Is this the on and off switch? So we are getting some continuity there, and I assume that that will change if we were to pull a valve. Okay, so as you can see now, that's gone open circuit. We'll put the valve back in and we should get our continuity reading back. Looking at the valve pins, they do look in pretty good condition actually. Normally it's not unusual to see, you know, things looking a bit green and tarnished, but no, they look good. Now we've put our valve in, we've got our continuity reading back. So yeah, it does look as though this radio will actually accept power from the mains, and I think we go ahead and we'll power it up now and see what happens. Okay, well, I think we're about ready to power this up for the first time, so I will give another safety notice that this is a live chassis radio, so we do want to avoid touching it when it's actually all powered up. However, I am actually running this piece of equipment here. You might be able to see it, but the socket that I have on my workbench here for testing equipment It's actually an isolated supply. It's being derived from an isolation transformer, so that should give me a little more protection. And if you are going to work on this type of equipment, I would recommend that you purchase an isolation transformer before doing so, because it is a good safety measure. However, even using an isolation transformer, it is still possible to get an electric shock. So I'm just looking at this little wall wart. It looks like I'm getting a 251 volt supply at the moment, which is not unsurprising because the supply to my house is pretty high. Also got a variac on the bench, so we're going to run the power up to the radio fairly gradually, and I'm also using a lamp limiter, so we've got quite a lot of protection and current limiting here. Now, before we go ahead and connect everything up, the other thing that I also want to just check is that the radio is actually switched on. Okay, so yeah, okay, it is switched on, and I'm going to turn the volume, I don't know, about halfway up. Now this radio hasn't got a plug on it, so I'm also going to be using my quick block here. And I think we'll use this digital meter to also monitor the HT voltage. Right, so we're ready to go. As we usually say at this time, place your bets. Is this radio going to work? Is it going to not work? Is it going to explode into a ball of flames? Your guess is as good as mine, but make your guess now. Okay, so everything's plugged in, we're now live. And we've got 100 volts on it. Let's see what we're drawing in terms of power. Okay, we're not drawing anything at the moment, 0.9 of a watt. Now, I wouldn't actually expect us to be drawing very much at this stage. Let's increase a little bit more. Right, we're at 150 volts now, and I can see our wattage is now shot up. Well, I say shot up, it's now 12 watts, so we're actually starting to draw a little bit of power. I'm guessing that the rectifier in here is, the filaments are at least starting to warm up, if nothing else. We're not developing any HT yet, but again, that's not surprising because I doubt we've got enough heat in the rectifier valve. Alright, 200 volts on here, and we're starting to build HT. 8 volts, 10 volts, 12, 15 volts, 19, 20. Okay, we've got 100 volts now, and we've still got less than 200 volts going into the radio at this point. So it looks like this radio is going to make good HT. Okay, we've got a station tuned in, can you hear that? Well, it's not very loud, but we've got something in the back of the box there. Let's increase the voltage a little bit more.
Britsh 1 for Burnley, and Leeds is 14, which is 19th in the division, as Bamford's in possession. He puts on a right foot half volley shot, but he was off balance and it spun off the outside of his weaker right foot and behind for a goal kick to Burnley.
Unbeknownst to him, the flag had gone up. We've just seen a decent shot from Lowton, but Melier saved it quite well. At the other end.
Could you make it out? How about now? The sound of a soldier keeping their heart rate steady, moments before knocking down the door of an enemy hideout. The sound of confidence that lasts a lifetime being made. Find where you belong. Search army jobs.
Well, this radio does actually seem a little bit deaf at the moment. It's not particularly loud, but it may be that it needs turning round. The radio reception aerial coils may not be very well lined up. Yeah, it's not particularly loud at the moment, so I would have thought with a little bit of recapping and realignment we can probably do better than that.
Can you continue this call?